The last type of queue is dequeue. Dequeue stands for doubly ended queue. So in dequeue I can perform insert and remove operations from both the ends. So if you see the class dequeue, I will write 4 functions for insert and remove. Insert rear will be there, which will insert the element from rear end. Insert front will be there, which will insert the element from front end. And similarly there will be remove rear and remove front for removal of the element from respective end. For full condition also I need to check 2 functions. One function will check whether the queue is full from rear end. Other function will check whether the queue is full from the front end. For empty condition I have taken the single function. So let's take an example so that we'll understand the algorithm for insert and remove operations. Suppose this is the array which I am using for storing the elements 0, 1, 2, 3, 4, 5. So at the beginning front and rear will point to -1. So this is the -1 index. Now when I insert the first element, I will increment both of them. That means when I perform the insert operation for the first time, rear and front both will come to 0 from -1. And then I will store the element. So suppose I want to store 15, so it will be stored here. Now from second element onwards, the algorithm will be different for insert rear and insert front, or remove rear or remove front. So suppose I insert the next element, which is 30, and I insert this element from the rear end. So in that case first I will increment the rear pointer, so R will come here, and then I will store the element at incremented index. So element is stored here. If I again perform the insert operation from rear end, say 45 is the element which I want to insert from the rear end, then first rear will come to the second index and element will get stored here. So anytime the rear pointer is pointing to the last element, front pointer is pointing to the first element. After that, if I insert one more element from the rear end, then R will be here and element is say 50, some element will be there. Now suppose if I want to perform the remove operation from the front end, so if I call the remove front function, then first it will return this element. This is front end, this is front end, this is rear end. So remove front will return the element at this index, and after that element is returned, front will be incremented and it will point to the first index. After that, suppose I insert one more element, then I am inserting that at the rear end, then in that case rear will be pointing here. After that, suppose if I remove one more element from the front end, then this element will be returned and front will be here. Now suppose if I want to insert one element from the front end, so in that case what I will do, insert at front end means I need to decrement the front pointer this time. So first front will come from here to here, and then element will get stored here. That means when I insert the element or remove the element from rear end, at that time I need to move this rear variable or rear index. If I insert the element or remove the element from front end, then I need to move this front variable or front index. So this is how insert and remove operations will perform. Now what will be the conditions for full and empty? So for full condition there will be two different functions. One function will check whether the queue is full from rear end. So in that case you will check the condition if rear equals to size -1. The other function will check whether the queue is full from front end. In that case you will check whether the front equals to 0. And when the queue will be empty or dequeue will be empty, if front and rear both are having -1 value, that means both equals to -1, then queue will be empty. So let's implement code for dequeue. I will declare a class dequeue here. The data members are first array of integer with size, where size is the macro. So let me take size as 5. Then there will be two more data members, one is rear and another one is front. In the public I will write the member functions for class deque. So first will be the default constructor, then insert functions and remove functions. Now there will be two insert functions as I told you. So insert rear for inserting at the rear end, and insert front for inserting the element on front end. Then remove function, remove rear will be there and remove front will be there. For empty and full conditions, for full condition, two functions, bool is full rear, which will check whether the queue is full from rear end, and bool is full front, which will check whether the queue is full from front end, and there will be single is empty function, which will check whether the deque is empty. So I will write the definitions one by one. Now what I am supposed to do in the default constructor. So in the default constructor I will initialize front rear to -1. So rear equals to front equals to -1. Then insert rear function I will write so in the insert rear function one argument is there, which is element to be inserted. Now how to insert from the rear end? So here first what I will check, so when to insert, if the deque is not full from rear end, then I will insert. So here I need to check if not is full rear, so it is not full from the rear end. So when this condition is true, that means it is not full, and in that case I will insert the element, else I will throw the exception overflow. Now when I insert the element, I told you that there is a different algorithm when I insert the first element, and the procedure is different when I insert the nth element. So when I insert the first element, at that time I will increment both rear and front, and I will store the element at incremented value, that means at the 0th index. So that thing I will do. So how to check that whether it is first time insert or nth time insert? So for that one more if condition I will write. So if condition will be if front and rear both are -1. So initially front and rear both are -1. So in that case it is the first time insert function which is getting called. So here I will check if rear equals to -1 and front equals to -1. So at that time I will increment both rear equals to front equals to 0, or I will directly write, I will make them 0, I will make both of them 0, and then ARR of rear equals to element, that is data. It will go inside the else part if the condition is false, that means if front and rear are not -1. So in that case I will increment the rear value first. So this is ordinary insert as that of linear queue. Increment the rear value and store the element at incremented value. So ARR of rear equals to data. So this will be the insert rear function. Now next will be the insert front function. So let me copy paste this definition and I will make the changes in the same definition. What will be the name? It will be insert front. If condition will be same, here I need to check if it is not full from front end. So if not is full, front, then insert the element, otherwise throw the exception. Again, one more if condition is there for checking whether it is the first time insert. If it is nth time insert, then here what I am supposed to do, if it is not first time insert, then it will come inside the else part, and here first I will decrement the front pointer or front index, and then I will store the element at front index. So ARR of front equals to data. So this is insert front. Then remove rear and remove front. So next function is remove rear. Now what you will do here, first thing you have to check if it is not empty, if the deque is not empty, that means if not is empty, then I will remove the element. If it is empty, then I will throw the exception underflow. So here it will be throw underflow. Now if it is not empty, now I need to check whether the element I am removing is the last element. So it is similar to the in the insert functions we have checked whether the element I am inserting is the first element or nth element. In the same way, here I have to check whether the element I am removing is nth element or last element. So it will be something like this. If it is last element, then what? If it is the last element, then front and rear both will point to that element. So you know that in deque, if there are n number of elements, front points to the first element and rear points to the last element. Now if both are pointing to the same element, front and rear, that means there is single element which is the last element. So that I will check here, if rear equals to front, that means if it is the last element, then I will do something which I will write here, and in the else part I will do something else. So what to do here, if it is last element, then I will return that element, or rather first let me take out that element in some other variable. Suppose let me declare one more variable here, int data. So I fetch the element which is last element in the data variable. So data equals to ARR of rear, or maybe front also you can write, both are same. Data equals to ARR of rear. After that I will reset the values of front and rear to -1, because since the last element is fetched, now the deque is empty. So rear equals to front equals to -1. I have reset the value, and then I will return the element. So return data. And if it is not last element, in that case I will simply return the ARR of rear. I am removing from rear side, so I will return the ARR of rear, and after that I will decrement the rear, so it will move to the left. So you try to visualize the diagram of deque which I have shown in the theory part, so that you will understand the definitions. Now remove front function I will write. Here if it is not empty, then I will check whether front equals to rear, so that thing will remain same. I will fetch the element, I will reset the value of front rear, and I will return the data which is fetched. Now here if it is not last element, then return ARR of front. So I will return the front side element, and after that I will increment the front value, so post increment of front. So I have written which functions? I have completed 5 functions: default constructor, insert rear, insert front, remove rear, remove front. The remaining function are is full rear, is full front, and is empty. So those conditions I need to write in the definitions. So here bool, then deque, is full rear. Now when the deque is full from rear end, if rear equals to size -1, so this will be the condition. So that's it, only single line definition. Then when the deque is full from front end, so that I will write in this function.
if front equals to -1. So front equals to -1. It is not -1, it is 0 if front equals to 0. And last one is if is empty. So when the deque is empty, if rear equals to -1 and front equals to -1. So these will be the definitions. Then in the main function I will create the object of deque and I will call the corresponding functions. So let me implement the menu driven program for that. So in the main function here I have declared the object of deque and there are two variables, one is data, other is choice. After that I have displayed the menu. First option is for inserting element from rear end, second option for inserting element from front end, third for remove from rear, fourth for remove from front, and fifth one for exit. So in case 1 I have taken one data from the user and I am inserting the element onto the rear end by calling the insert rear function using the deque class object, which is deque. I have put this in try catch so that I will handle the exception overflow. In case 2 I have called the insert front function here. Then in case 3 I am removing the element from rear end, so I have called the remove rear function and the return value I am displaying onto the console. In case 4 it is remove front which is getting called. So every time I have written try catch so that necessary exceptions will be handled for overflow and underflow. Case 5 is for exit. So now let me compile the code. It is throwing some errors, semicolon missing, so let me check. Here when I throw the exception I did not write semicolon here, then here also when I throw the exception semicolon should be there after that. Here it is there. Okay, again let's compile. Int deque scope solution remove rear previously defined. So remove rear, this is remove rear and this one is also remove rear. Okay, I did not change the name for front side removal, so it should be remove front. Now let me compile. So it is getting compiled. So if you want you can add one more case to display all the elements of the queue. So suppose here I add one more case where I am displaying all the elements. So case 5 is for showing the whole deque. So show is the option and 6 for exit. So for that I need to add one more function in my deque class which will display all the elements of deque, which is show function. So here I write void show. How will be the definition for this show function? Void deque scope solution show. Now here I will display all the elements inside the deque. So for that what I will do, I will start from front, I will go till the end and I will show each index element. So there will be a traversal using some variable, say I. So I start with value front, I go till a rear, so I not equals to rear, I plus plus, semicolon every time, and display ARR of I, so that when you run the program you can actually see the contents of the deque. And at the end I will change the line. I need to write case 5, I need to change case 5 and I need to add case 6. So in case 5 I will call the function show. So deque dot show here and case 6 is for exiting from the program. So here it should be exit 0. Now let's run. So suppose I insert 5 elements, or say 3 elements, 10, 20, 30, 10, then 20, then 30. So all inserts are from rear end, so the deque is 10, 20, 30. So if I say 5, then 10, 20 is printed. Okay, so the condition I need to change here in the show function, it is less than equals to. Instead of not equal to, it should be less than equal to. Now let's compile. So suppose I insert 3 elements, 10, then 20, then 30, and if I say show, then 10, 20, 30 is the output. So all the elements are stored at the beginning of the deque. Suppose now I remove from front. So remove from front is fourth option. So 10 is removed. Now deque contains only 20, 30. So if I again show, it is 20, 30. If I insert from front, that means second option, if I insert 100 element, then deque should be 100, 20, 30. So fifth option will give me 100, 20, 30. Then remove from rear. If I remove from rear, then 30 is removed. Again show 120 only. If I insert few more elements, say 12, then 24, then 36 at the rear end. After that, it is displaying all the elements. And now if I insert one more element from rear end, say insert at rear, say 1, 2, 3, then overflow is displayed. So this is how queue will work. So this code is working. You can try different combinations of insert and remove operations, and you can check the validity of the code. So this was about the deque. Thanks for watching the video. Please like the video and don't forget to subscribe.